Good morning, everyone. This is the quiz solutions video for quiz 5. So let's get started. Let me change to the drawing tool, like I always forget to do ahead of time. So it gets a little bit, cumbersome. There it goes. So this is quiz 2, and it's a very sunny, bright day today, so that bodes well for your exam. Did I say quiz 2? It's quiz 5. It's quiz 5. All right, for the first question, right, which of the following cycloalkanes has the least angle strain? Well, remember, an alkane, whether it's a cyclo or not, has sp3 hybridized carbons, right? And sp3 hybridized carbons have 109 degrees as their most optimized bond angle. And as we go through these guys, right here, right, this cyclopropane right here has 60 degrees, right? Cyclobutane here has 90 degrees. Cyclopentane has 108 degrees, which is pretty close. 120 degrees here for cyclohexane. Whoops. 120 degrees for cyclohexane. And then 129 degrees for, 129 degrees for cycloheptane. But the thing here is that if you were just to go and choose based on the numbers as they were, right, then you would get it wrong because you choose cyclopentane, because 108 is really close to 109. But remember that these molecules are not flat, right? They're absolutely not flat. They're bent, contorted, and conformed in such a way that it makes them most optimized in their particular angle, bond angle strain. So the one that contorts and conforms the most to alleviate all this strain is cyclohexane, because when it turns into its chair or boat conformation, the angles are indeed 109.5 degrees, or very close. So the answer here would be D. Which of the following is the boat conformation for cyclohexane? You can just take a look at that there and see which one looks like a boat, right? Definitely not that one. That's just a Haworth projection that's flat. That's just a structural drawing that's flat. That's a chair conformation. That's a contorted, weird-looking boat thing, but it's not a boat conformation. So the answer is A here. For number 3, for the following cyclohexane, identify the substituents as being axial or equatorial. Bromine is pointed up, so that means it's axial. Chlorine is pointed to the side, which means it's equatorial. So the answer there would be A. All right, let's keep on going here. Keep on going. We're on a roll. Which of the following chair conformations which of the following is the chair conformation for the following substituted cyclohexane? And I'm sorry about the weird, the way it looks so weird on mine. I don't know if it looks like that on yours, but it's gotten flattened out and stuff. But that doesn't matter. You can still see what it is. So none of these are chairs right here. Those aren't chairs. Okay, that's not a chair either. Okay. And then so that leaves us. That leaves us with either this one or this one, right? Well, if you remember, I said that the equatorial at the top right here, right, has to be pointed so that it's not diagonal but parallel with this bond right here, right? Because remember, if it were axial, it were pointed up like that. Okay. If it can't be this one, because this one's pointed, even though it looks equatorial, it's also a boat conformation. So it has to be this, because it's asking for the chair conformation. So that's definitely, the answer there is C. Identify the most stable chair conformation of 1,3,5-trimethyl cyclohexane. This one's really easy too, because you remember in one of my slides I said that the more substituents in the equatorial position, the more stable it is, right? So the only one that has most of them in the equatorial position, right, is this one, structure 4, right? This has an axial, this has 2 axials, this is all 3 axials, and this one has an axial. And remember, when you have an axial, when you have like the 1-3 diaxial interactions, and that's just a pain in the butt for those guys. What is the relationship between these two compounds? These two are actually identical, right? You would at first think that that these would be enantiomers of each other because they have up-facing and down-facing constituents right there. But remember, this is just a CH3. This is a CH3. So that's a CH3. That's a CH3. It has symmetry right there, right? So these guys are actually identical to each other, right? Because they can rotate around and be like the same, right? So you could indeed rotate this guy, and it would look the same as this guy. Okay, so they're identical. Next, what is the relationship between the two following compounds? Now, these are definitely not symmetrical because these are 4 different substituents right here, right? And then you have a proton right there, right? 4 different substituents. So already you know that this is a chiral center. And there's a chiral. If there's a chiral center there, what is it? It's definitely not a constitution isomer. Definitely not identical. It is a stereoisomer, right? So the answer there is B. What is the best term that describes the alkene below? Both of these on opposite sides. That means it's a trans only. What is the which is the best term that describes the double bond indicated by arrow below? This is Crestor. Reduces your cholesterol. It has a double bond right here, and both substituents are on opposite sides. So again, this is B, trans only. And then the last question, indicate which arrow indicates the chiral center of this compound. It's hard to tell here because, right, you don't see the dashed and wedged bonds, but that's okay. Here we have some symmetry, right? Can't be that one. Here we have some symmetry too. Can't be that one. Because remember, these are double bonds that can go around like that, right? So that's all symmetry right there. And then there's a proton, right? Let's come off there. So those aren't chiral centers, okay? This guy right here also has some symmetry too. All 3 of those on that ring have symmetry. This one here has a methyl, a proton, and an amine, and this guy. Okay. And then this one here has an OH, the benzene ring, a proton, and then this guy. So the answer would be, I marked all over it, but I think that's A and B. So the answer there is E. And that is the end of the quiz, I believe. So if you have any questions, ask me. But at this point, actually, as I'm looking at that, that's not right because that arrow is pointed to, this A arrow is pointed to that one. Sorry, my bad. That's what happens when you draw over your stuff. You can't see anything anymore. That's the one pointing to this, right? So it's actually B and C. Make sure you pay attention to those arrows. The answer is C. Okay. At this point, the quiz is already open. I mean, not the quiz. The exam is already open, so I can't answer any more questions because there's no way of me telling whether or not you're actually taking the exam and asking me a question to help you on the exam or not. So at this point, I cannot answer any more questions. So good luck on your exam. Make sure you have it turned in by the end of the day. And I'll see you on Monday for the next lecture.